นี่ใช่ไหมครับกดอันนี้ได้เลยใช่ไหม Okay, sorry, technical problem. Alright. เสียงสะท้อนนะครับได้ครับ Okay, so yeah, continue from what I said. We have something called lane to send something from one chain to another chain. Let me get my pointer again. So this thing is called CCIP lane. If you want to send something from chain A to chain C, we have CCIP lane, and this lane is something that called unidirectional. So you can either send from one chain to another chain with only one way. But if you want to send something from chain C to chain A, we're going to have a separate lane to do that. This is designed to be security first. That's why we designed this way. And to use CCIP is really simple. This is just the basic diagram that you have to know to send something using CCIP. So first thing first, you got to have your message. And the second thing is the destination chain. And I want you to conceptualize it as well, imagine you are sending something to the via postal office, right? You got to have the envelope, and you wrote the zip code in the envelope, and you send to the post office officer, something like that. And in CCMP, it's the same way. We have our message and we have our destination chain to specify what chain we want to send. And then we send to router. And this router is going to handle the work of sending this transaction cross-chain. It's going to pack your data, and it's going to send this transaction through the best lane possible that help you get your message to the chain as fast as possible. And in the destination chain, we're going to have router as well. This router is going to send the data or send the message to the destination receiver on another chain. Okay, so this is the basic thing that you need to know to use CCIP. But this diagram, it might be quite complex. This diagram is how CCIP is working in deep details, but I don't have a lot of time in this session because we going to explore on how near BOS working. So I'm just going to explain this one quickly. So CCIP, to make CCIP work, we have two systems that working to verify each other. So we have this thing called committing dawn and executing dawn. This part is the actual network that working on the verifying. So is the blockchain that working on committing the transaction or checking the transaction and verify if it's real or not. But to make sure that committing dawn and executing dawn is working correctly, we have another system called active risk management network. And this active risk management network is going to verify if the committing dawn really verify the right transaction to be able to send there. I think it's checking the Merkle tree root to prove if it's valid or not. And these two systems is working together to make CCIP really safe and secure, right? Yeah, and that was all about the theory that we're going to talk about today. And we're going to get to our workshop. Yeah. So yeah, first thing first, I want you to go to this website. This is the website that I host all my code that we're going to use in this workshop. Okay, so I'm just going to stay on this page for a while. Okay, so meanwhile, if you have any question, you can raise your hand. Okay. Well, let's say if you get into the website, you will see something like this. Okay. If you cannot access the website yet, please raise your hand. Okay. Let me get back to the URL. Yeah. Oh, the Wi-Fi.ครับอ๋อจริงด้วยผมลืมเดี๋ยวคือพอดีเซสชันเนี้ยครับเรามีคนต่างชาติเยอะครับเดี๋ยวถ้าเกิดมีปัญหาอะไรหรือว่าฟังไม่ทันตรงไหนสามารถเรียกคุณแก๊งได้เลยครับโอ้หาที่ครับถามไปแล้ว
เขาบอกว่าคุยแก๊งมากตรงนี้เลย
นะครับ Okay, I think everyone already get the website, right? Okay. I'm going to walk you through the website a little bit on what I put in here. This is going to be the reference if you want to replicate this workshop later. So in this slide, right, I put the slide. This is the slide that I have in this workshop. So if you want to explore more on what I already talked about, you can see that there's a slide over here. You can take a look at it. And yeah, the first thing first that we're going to talk about is the basic CCIP. This is what we already discussed. And yeah, to start the workshop, I want to start on the smart contract structures that we're going to build in this workshop first. So in this workshop, we're going to build 3 smart contracts. Yeah, we're going to build 3 smart contracts on 2 chains. The first chain is the Ethereum Sepolia, and the second chain is the Avalanche Fuji. And on Sepolia, we're going to deploy 2 smart contracts. The first one is going to be the NFT itself. It's called MyNFT, and it's going to be based off ERC 721. And on Sepolia, we're going to have second smart contract called CCIP Token and Data Receiver. This contract is going to receive some data, and it's going to call the method called mint on the MyNFT contract, so to mint the new NFT. And across Sepolia, we have Fuji, right? On Fuji, we're going to deploy only one smart contract, which is CCP token and data center. This smart contract is going to transfer something. It's going to send the data that we actually click on it and interact with it. And after we interact with it, it's going to send that data cross-chain using CCIP, and it's going to call mint NFT on the Sepolia, which is the destination chain. Okay, so this is the basic structure. I'm not sure if you guys have any question on it. Okay, if not, I'm going to continue. Okay, so for today workshop, I'm not going to go in depth on how to get ETH or get AVAX and a lot of things that requiring to do before this workshop, because we have Pita right here. He's waiting for me. He's going to tickling my ear if if I'm going too long. So yeah, please make sure that you got your ETH and link on both Sepolia and AVAX and link on Fuji. I just put the faucet website right here so you can get it real quick. Okay, and well, let me give you a quick example on how do I get that. So let's say I want something on Sepolia, right? I just head to the website and I'm going to see something like this. The first thing I have to do is to connect the wallet. Okay. And after you connect the wallet, you can verify if you are really human. I think I'm a human, so I'm just going to log in with GitHub. And then just hit send request. So it will initiate the transaction and give you the link token and the ETH that you need. You need to do this on both AVAX Fuji and on Sepolia to get the required tokens. And I'll see in my MetaMask if I already got the tokens. Oh, okay, so you can see that I use Ledger for me. I got it on Sepolia already. Yeah, both Link and ETH, and on AVAX. I already have on AVAX, so I won't require another one. But if you have no tokens on both chain yet, just ask for the token on the faucet. Okay, this is the first thing that you need to do. Right? Now let's start with our workshop. Okay, to start our workshop, I recommend to use Remix. If you want to use Hard Hat or some other framework, you can do it. But for the demonstration and to make it really really fast, I'm going to use Remix. So I'm just going to head to remix.com. Okay, so we got our lovely IDE right here. Once we got here, I'm going to hit on create a new workspace first. And I'm just going to leave it as blank. And for the workspace name, I'll call it BOS. Okay. Then I got my empty workspace right here. The first smart contract that we're going to build is on the Sepolia side. So just head back to the website and just copy the first snippet over here. Okay. I'm sorry, I forgot the name. So it have to be CCP token database. I'm going to create a new file and I'm going to name it CCIP token and data receiver. Okay, so this is our first smart contract. And I'm sorry. Let me zoom in. Okay, I hope you guys see it. Okay, for the first smart contract, I'm just going to paste the code that I got from my website, and you will see something like this. It's just the normal remix thing. Don't worry, it's not at risk. Believe me. Okay, so for this smart contract, I wrote 2 contracts on this file. The first one was my NFT that I told you. This is the NFT itself is ERC721 compatible. And the second one is the CCP token and data receiver. This one is the contract that's going to listening to the CCP call. Let's start on the first one, on what we are doing on the first one. So the first one is the NFT contract, right? This is a very, very simple smart contract. So what we are doing is that we just implement this thing called ERC2021 UI storage. And this one we imported from OpenSuplin. So OpenSuplin, they gave us the template that already implement the ERC721. So we can just implement it, and we're just going to override some function that we're going to use. Okay, so the first thing that I do is that I add this line over here. I add the new variable called token URI, which is actually the URI of the NFT that is going to point to the PNG of the NFT of ours. So I'm just going to copy this one and head to the browser. And you should see something like this. So this is the metadata of this NFT. We have the name, we have the description, and we have the image. If you want to see the image, it's look like this one. Cute guy. Okay. All right. And yeah, the second thing that we define is the token ID. This one we're going to keep track of what token ID this NFT is. And then we just have the constructor. This constructor is really simple. We're just going to supply the name and the ticker of this NFT. And we're just going to skip the function that we put in the constructor. So we don't do anything. Just have a blank constructor over here. And then we build a new function called mint. And this function is going to be the real function that we're going to execute to get a new NFT. Right. So what we're doing this is we add save mint, we set the token URI, and then we just increment the token ID. Okay, so this is a really basic one. All right, and yeah, that was the first contract. And for the second contract, this contract is actually the contract that's going to implement something from CCIP. We call this CCIP token and data receiver, right? And the reason why we built it is because we're going to use it to receive something from CCIP. So the first thing that we do is that we implement this thing called CCIP receiver to receive something from CCIP. And we first start by defining the NFT itself. So we call it NFT. And we also define the event that's going to be emitted when the mint is success. So we call it a mint call successful. And on the constructor itself, it's really simple one as well. So we're just going to invoke this constructor called CCIP receiver. And this CCIP receiver is going to be the part of the contract that interact with the CCIP protocol. So I have to, just supply the router address because this one is the router that this smart contract is going to talk to. And after that, I'm just going to create a new NFT by using a new keyword right here. So I'm just going to create a new NFT and make it linked to this smart contract. All right, so that's for the constructor. And the second part is the CCIP receive. This function we override. So if anyone if anyone interact with this smart contract via CCIP, this function is going to be invoked. And if it's got invoked, what I want to do is that I just want to call something. I just want to call with the message data to the NFT itself. And well, this line is going to be some kind of abstract to you right now, but I can ensure you that in a minute we will explain more about this one. So yeah, basically I want to call this NFT with the message.data that we receive from the CCIP protocol. And then we're going to destructure this variable called success. And we're going to require if this is success or not. If it's not success, this transaction will be revoked and it will be failed. And then we're going to emit the mint call successful. And yeah, it's not really hard, right? I believe. So yeah, that was basically on what you need to do for the receiver side, I'm just going to quickly deploy it. Okay, so to deploy it, I will head to this this tab first, the deploy and run transactions. And for the environment, I'm just going to change to injected provider. And it's just going to pop up my MetaMask. I'm just going to use MetaMask. Okay. And on my MetaMask, I'm going to make sure that I am on the Sepolia chain. Where's Sepolia? Oh, it's on. I'm going to check Sepolia on my MetaMask, so I am on Sepolia, and you can check if you are on the wrong chain or right chain on this one. So make sure you are on Sepolia on the first smart contract. Okay, so as you can see, I'm already on Sepolia right here, and I will deploy this smart contract. And to deploy it, the thing that we have to supply is the router address. And you might wonder, how do we get the router address, right? So to get the router address is quite simple. You just have to head to CCIP documentation. So just search on Google CCIP documentation and search for something like supported network. Oh, I'm just going to show you how to Google it. So CCIP supported network. And you should see it at the front page. Just head to the first website. And after I got here, since I'm using testnet, I'm just going to pick this 1.2.0. And I'm going to deploy on Sepolia, so I'm just going to hit on this drop-down menu. And in this documentation, it's going to provide all the details that you need for deploying some smart contract with CCIP on each chains. So yeah, it's going to give you router address, the chain selector, and supported fee tokens. And what I needed the most is the router address. So I'm just going to copy it right here. And then just head to Remix. And I'm going to put it here and hit transact. Okay. And then we just hit confirm. And then let's wait a while. It's going to deploy a smart contract first. Okay. So after the contract is deployed, this is the smart contract that we have. So we have CCIP token and data receiver. And we also have this function called NFT. So this smart contract, after deploy, since the constructor is invoked, is going to create a new NFT first. And you can use this address to see if your NFT is already deployed or not. And that's it. That's all for the receiver side. I'm going to pause here a bit. If you have any question, please raise your hand. Okay, I think everyone is genius right here. Okay, I'm just going to continue to the sender side then. Okay, so for the sender side, we also have only one smart contract, and it's quite long, so I'm just going to hit withdraw and just going to Command A and copy all of it, and then hit to remix. I'll create a new file. I'm going to call it CCIP token and data center. Okay. And then we just have to paste the smart contract that we already copied. Okay, so it's this one over here. This smart contract, its job is just to send some data to another chain. Yeah, I'm going to explain it line by line on how does it work. All right, so this smart contract, as we call it, token and data center. So what it does is it's going to send some data cross chain, right? So the first four things that we have to define is for this one right here. The first thing is the router. This is going to be the router that this smart contract is interacting with. And because of this smart contract is going to be the data center, we have to pay some fees on the sending process. So I just going to define the link token interface, which is the token that I'm going to use to send some as a fee to send some transaction. And then we have to specify the destination chain selector. This is the just the postal code of the place that you want to send the transaction to. And the last one is the receiver. This is the address of the smart contract that we already deployed on Sepolia. So we have to define four of these things. And after that, I will create this mapping called whitelisted chains. And well, this mapping is going to be the whitelist chain that we able to send some transaction to. And then I'm just going to define the error. So we have three errors right here. The first one is not enough balance. Second one is destination chain not whitelist. And the third one was nothing to withdraw. So not enough balance is going to be invoked when we don't have enough link inside our contract. And the destination chain not whitelist, this error is going to be invoked when when some transaction is built on the chain that we are not whitelist. And the third thing is nothing to withdraw because we're going to send some tokens to this smart contract, right? I have to add the withdraw function so I can withdraw the tokens inside this one. So I add this error, nothing to withdraw. Okay. And we're also going to define the tokens transfer. So we have this event called tokens transfer, which we're going to emit it after we finish invoking the message sent. So I include 5 things inside this event. The first one is message ID. The second one is destination chain selector. And we have receiver, fee token, and fees. And on the construct, this is very simple. We just have to specify 4 things, which is router and address of link and the destination chain selector and the address of the receiver that we're going to send. That we're going to send the CCIP message to. All right, so we're just going to set it right here. And we also have mint NFT function right here. Sorry, it's error on this line. But let me just remove this one. Okay, so this mint NFT is going to build some payload for the NFT on the CCIP message. And we're just going to send this message cross-chain to the Sepolia. And what we do is very simple, which is we first start by build the CCIP message. And we have a handy function called EVM to any message, which we have to specify these 5 values to build a CCIP message. The first thing is the receiver itself. what address we want to send the request to. So it's going to be the API encoded of receiver address. And the second one is the data. This is going to be the data that we send cross-chain to Sepolia. And we're going to encode it with the signature. And we're going to call the mean address with the address of the sender. And we can also specify the tokens amounts that we want to send. Well, in this case, we don't send any tokens, so I'm just going to leave it as empty. But if you want to send some data, you can invoke this constructor to build some event tokens amount message. And for the extra argument, this one I just specify the gas limit. You can make it really high, but I just going to put 20. How much is this one? I don't know how to call. I'm sorry. Yeah, and we also specify the fee token, and I just going to put the address of the link token right here. And after we finish build the CCIP message, we're going to get the fee that take to send this message. So we call to router with the get fee function. And then we just put the destination chain selector, which is the postal code of the chain that we want to send to. And then just put in message that we just built. This function is going to estimate the fee that's going to be taken if we actually invoke this function. And then we check if the link token that this smart contract has is more than the fee that it takes. If the token that we have is not enough to pay the fee, well, just don't waste the transaction. We're just going to revert it that we cannot do it. Okay, so yeah, after we check the fee, I'm just going to approve to the router that we will allow router to use link token with the amount of fees that we already calculated. Yeah, and well, all of this that I talked about is only the preparing side, but the very easy side is on the send itself. So when you want to send something using CCP, it's really simple. You just have to invoke this function called CCP send, and you just have to specify the destination chain selector and the message that you already built. And after that, I'm just going to emit one event called token transfer. And yeah, this one is vary on what you want it to invoke, what you want it to emit. So you can freely put anything you want right here. So yeah, that was it. That was all of the mint NFT process. So yeah, you have to start by build the CCIP message, and then you just have to check if you have enough fee to pay for it, and then you just send. And after send, you can emit some event. That's all. So this is how you send data cross chain. All right, and well, as I said that we have to transfer some token into this smart contract, right? That's why I include this withdraw token function. So if I don't use this smart contract anymore, I can withdraw. I can withdraw the token that I don't need, that I want to use it later on. So it's just a really simple function to withdraw the token. All right, and this is it. This is the sender side, and we're going to deploy this sender side on the Avalanche Fuji. Okay, so yeah, I'm just going to head to deploy and run transaction, and then I'm going to change my chain to AVAX, Fuji. Okay, so just make sure that you are on this network, you are on Fuji, so you don't deploy on the wrong chain. And to deploy it, you have to specify quite a lot of things because On the sender side, you have to do a lot of things. So yeah, I'm just going to first start by add the router and link and destination chain selector. All of these three values we can get from the CCP documentation. Just going to drop it here. We are on Fuji testnet, so just hit on Fuji testnet, and then just copy the router address and put on the first parameters here. And for the token that we're going to use as a fee, we're going to use link. So I'm just going to copy link address, put it here. And for the destination chain selected, this one, we're going to have to go to Sepolia and get the chain selector right here. I'm going to put it here. And for the receiver, this is going to be the address of the contract that we're going to send the transaction to on another chain. And that is the address of the first smart contract that we deploy. So right here, just going to copy it and put in the receiver right here. And then just hit transact to deploy it. Okay. And just going to hit confirm. Yeah, it's already deployed. AWAC is really fast. Okay. And yeah, that was it. That was all smart contract that you have to deploy. To test if the smart contract you already deploy is working or not, you just have to supply some link into the last smart contract that you deploy, which is the sender. So I'm just going to copy the address and then head to MetaMask. Make sure if I'm on AWACS and click on link and hit send right here. And I'm just going to put the amount of link that I think I need. I'm going to put 5 and then just hit next and then hit confirm. Yeah. And this is everything. This is everything that you need to do to make some transaction cross-chain. Let's wait for a while. And if you want to make sure that this smart contract is really working, we can check by hit on this mint NFT function. And after you hit on this mint NFT function, this sender smart contract is going to send some transaction cross-chain to the receiver. Just going to hit mint. And my MetaMask pop up. Just going to confirm. Okay. And yeah, the transaction is completed. So I'm just, another thing that you can do after you already send some transaction is that you can copy the transaction hash right here and check if it's already sent it or not on the CCIP Explorer. So just hit new tab right here, CCIP Explorer. Go to ccip.chain.link. Yes. Okay, and then I'm just going to paste the transaction that I made on our launch. And on this Explorer, you can see the CCIP transaction in details on what message ID is going to be and what is the source transaction. And after the transaction is completed, after we already sent the data cross-chain, you're going to have the destination hash. This is going to be the transaction that made on the destination chain. And you can see that I sent from source chain to Ethereum Sepolia. And it's going to take a while before CCP can finalize everything, before the executing dawn, before the committing dawn working together with the active risk management network and all of that thing. So it's going to take a while. But meanwhile, I'm going to show you what the final transaction is going to be like if it's completed. So let me open my node real quick. Oh, I'm sorry. You can head to my website. This one right here. So if you want to see what's the transaction going to be like if it's already completed, I already put in on this part, deploy contract. And you can head to this transaction hash, which I included. So this is going to be the transaction that completed and the data is sent cross-chain. You can copy the transaction hash right here and head to the CCP Explorer. We just put it here. Yeah, if it's completed, it will look something like this. So you will have a green mark right here called success. And you can see if the NFT is already minted or not, which in my case is already minted. Let me get my node again. Oh, wait, that's it. Okay, right here. This is the NFT of mine. I can copy this address and head to testnet.OpenSea.io. And then just paste my address of my NFT. Okay. And you can see that this NFT has two NFT in the collection, which is the first one was mine. And I think the second one was done by Pita when he's testing this workshop. So yeah, that's basically wrap up this workshop of mine. Yeah.
Where did you get this contract address? So when we create it, how do you get it?
Yeah. Let me head back to my code on the remix. You mean the NFT address, right?
Yeah.
Yeah.
See on OpenSea.
Yeah. On the receiver side, I just define this function, this variable, right? And because it's public, you can see it right here.
Okay.
Yeah.
And the address of this NFT,
Yeah.
it's like a new one that's been created there.
Yeah, on the constructor, yes.
Okay.
So when you deploy this smart contract, the constructor is going to be invoked, right? And when it invoked it, we're going to create a new smart contract by using
this smart contract. This is like a new smart contract when it needs new NFT. It is like not the address of smart contract that's been deployed. It is not the address of CCIP token and data receiver.
No.
It is different.
Yeah,
okay.
it's
Okay.
yeah.
Okay, no next question.
Okay, thank you. Okay. And yeah, that was all my workshop. I'm going to head back to my slide real quick. So if you want to learn more about CCIP, I have a reference right here. We have a documentation on docs.chain.link, and you can take a look on details on it. Or if you want to get to see the Explorer itself, you can go to ccp.chain.link. This is the Explorer that I just showed you. We also have this starter kit, a hard hat kit, and the kit book made by Andre, and article made by Elif. You can take a look at all of these references to learn more about CCP.
Sorry, I have a quick question about the fee token.
Yeah.
with the current version of CCIP, can you use other tokens yet, or is it only
No, you can use only the token that specify on the documentation. So for each chain, it would be different. Like for Sepolia, you can use Link, you can use Wrap ETH, but on Mumbai, you may be able to use Link and a Matic.
And does it get converted to Link right now?
Yeah.
And when you use, let's say you use a different token other than Link, I know that there's like a 10% fee, like a premium, right? No?
I don't think so. Yeah.
I saw that they put out some info saying that you can use other tokens, and it's a little more expensive compared to Link.
Yeah, because you have to convert it to Link, because the actual people that does all of these cross-chain transaction for you is the node on the Chainlink network, and in that network we pay in Link, right?
Yes. So I was just wondering that because you use you call it a get fee function, right? And I was wondering if you were using a different token other than Link. In that get fee function, does it add premium for you already? Or no?
Well, let me dig into that later. I don't have any. Okay. Sorry. Is there any questions?
Any questions?
Okay, I think that was it. Okay. So yeah, well, as Joy said, if you want to join our communities, we have QR code right here. We are really lovely communities, so please join us. And we're going to run a hackathon as well. So yeah, please vote for us, Ayara Wallet. Okay, see you.
Give me a second for setup. Are you guys hungry yet? Please wait for about 30 minutes.
Let me search it
Pizza
for you.
arrives. Fish, so take care of yourself.
Okay. Are you guys excited about Chainlink CCIP, execute one chain and transaction through another chain? So, sorry. ขอโทษไม่เห็นหน้าจอใช่ครับอ๋ออันนี้พี่ต้อง
ต้องเชื่อมกับจอแยกครับคนละส่วนกัน
แล้วเขาเชื่อยังไงสิ
เดี๋ยว
พี่เก่งเชื่อยังไง
มันจะมีชิปกันเนี่ยผมเรียกคุณฟ้าครับ
อ๋อนี่เหรอไม่ใช่
มันจะเป็นไอ้นี่ต้องใช้กับตอนนี้ครับ
Technicality issue is bear with me. Uh, มันต้องต่อต้องต่อ Wi-Fi วงเดียวกันใช่ไหม
ต่อ Wi-Fi เหมือนเครื่องเมื่อกี้เลย
ต้อง
อ๋อ
ต่อ Wi-Fi นี้ เพราะว่าแค่วันมิทติ้งมันเชื่อมกับทีวี
อ๋อโอเค
เป็นแค่วันมิทติ้งค่ะ
เข้าใจแล้ว
แล้วก็เซตอัพมิทติ้งตัวพิมพ์เลยทั้งหมด มีด้วยนะคะเซตอัพมิทติ้ง
Sorry for technicality issue. Hi. So now I think you got loaded with the smart contract Solidity, right? Now it's come with the casual session, but leverage from that part, right? So I think if you understand CCIP, basically is you have to execute smart contract to remix or even either scan, for instance, right? Otherwise, you cannot interact with that. Or if you know good enough with the library called EJS, you can build everything from scratch, right? And you build the apps on top of that. So before I go to that part, give me just about a couple minutes to introduce what is near BOS. Okay. Near BOS stands for Blockchain Operating System, and we're gonna deep dive to it within 5 minutes. What is that? So as you know that, right, NEAR is a alternative layer one for since early 2018. If wrong, please bear with me, okay? So their journey from layer one blockchain from 2018, right? And furthermore, 2 years later, they try to convert themselves to be a dev platform, right? Anyone can write smart contract on near layer one. And also that year, they announced Aura, which is an EVM layer two of near, which is EVM compatible, right? They're quite done pretty good in the bullish market last 2 years. But now, from 2023, they introduced a new product. It's called Blockchain Operating System. And anyway, they go on to on-ramp 1 billion user for near blockchain. I think many of you guys are investor for near, right? I am as well. I bought ICO near from day one. Okay, I sell that, but I buy it again. Okay, so who knows? Okay. Okay, so let's figure out what BOS component is trying to solve, right? If you see the graphic over here, is you can see it's okay. You know that Web3 or smart contract is already decentralized by themselves, right? Because the code is law. You can know that there are many exploits in the world. I think last 2 days ago, there are some protocol already exploit. But anyway, you know that you heard yourself, right? But there is one problem that you cannot figure it out. If someone try to spam the website or try to pretend to be yourself, something like that, there is no solution for decentralized front end yet, right? Because if you got hijack your domain or hijack DNS, and your user come to your platform without knowing they're doing with the hacker itself, right? Near try to elaborate that part. So basically, BOS component, I will summarize for you just with 2 words. It's called decentralized front end. It means that the front end that you can read it easily, what the contract that they call, what the API that they use in each front end. So there are many protocols built on BOS. For example, like Aave, like Lido, like many swap on BOS component. You can search on near.org. That's what we're going to solve. It means that it's connected to Chainlink, right? Because Chainlink want to execute mint contract from Amazon, right? And then mint it really on Ethereum Sequoia, right? This workshop gonna show you how gonna do that on BOS real quick. Okay. So that's the layer. The thing that I want to highlight is a gateway layer. The gateway layer basically is your apps. Actually, this layer you can do by yourself, but you doesn't have to. Most of developers they do into this layer is called layer component layer. But feel free to fork gateway is open source, components open source, so you can do that if you want to. But this line is like service layer. You can call any service. For example, you can call ChatGPT. It's possible, right? Because you get an API, you get token, build it inside the front end. Okay, it's not a good practice, but you can do that. By the way, the last layer is you can call any front end, any EVM, or even call smart blockchain. You can do that, right? This is stack of BOS. Also, this is some example for authentication or near, etc. And this is a summary of BOS. No longer trade-off about decentralized world, right? Because front end now can really decentralize. Of course. So I don't want to dig too much about the details. So I think we are coder, right? We are builder. I will show you the code real quick. Should be quick. This is one of the gateway that built in. You can fork and you can use it for free. You can fork to do yourself, tweak it, modify it, whatever you want to do. The thing is, this code is written in JavaScript and embedded in near layer 1 blockchain. So basically, this component you're gonna get. You see that this component. You can see that this is one of the gateway that I use, right? But if you're going to the official gateway, is near itself. You can go to near.org, right? And you can discover and also component. Actually, near has the component name filtered by your ID. For example, my ID is shannon.near. This is the component that I already done. So if you can search my name, you can see I have component on official website. You can click on that. This is also the code, right? You can open it here. Yeah, and it's also showing that I didn't select the right network, right? Because now I select what network did I call? Now it's a linear mainnet, which is layer 2, right? So if I switch to Avalanche Fuji testnet, is alive my component. So basically, it's like only JavaScript technical, right, to detect your chain. But you're gonna see that it's the same, right? So basically, it's one gateway. This is also one gateway that you didn't have to build it. You just build a component that's with JS inside of it. So basically, what's code do? So I'm gonna show you the result, and we can see the action later. So if I go to the Avalon, right, I just allow the function, the user function, allow user to mint the NFT, right? Mint on Fuji chain. But if I'm switch my chain to Ethereum Symphonia, it's gonna be like this. So I'm not let user allow to mint, right? That's only let user allow to view NFT. So I click on it, yeah, my NFT is appear. Because I detect that my wallet has some NFT, right? I query from the IPFS, right? The smart contract. So this chain, if I'm going in Symphonia, I can show my NFT. Otherwise, I cannot. So basically, you can tweak it and play with it. So now I'm going to show you some code, how it works. Okay, zoom in a little bit. Yeah. Basically, you can go to my component. You can see the process. Everything that you understand, non already explained earlier, right? This is the front end layer to execute smart contract. So it's just only about 150 line of code, so it's very small component, right? Let's see how it works. So this is a state that is like global state that I store the value. So I'm allowed view NFT, image, and name. So the first two variable is just check the current chain that user already connected. Because if they connect one chain, they shouldn't do the action from another chain, right? So I build this logic. So I'm gonna make sure that user not gonna confuse. Everything is shown here, right? So I'm allow user to mint in for the correct chain. This is a state that view NFT, right? So the value is to return true or false, right? If it's true, disable this component. If it's false, enable it. So basically, it's just state. This state gonna change when the component detect the user current chain. All the things is done by JavaScript, right? That's this line of code that detect the chain. So basically, the library that we have used is just either JS built in within the BOS component. So I'm going to detect the MetaMask option, right, to check which chain it is. Now I'm hardcore with the 43113, which is Avalon Fuji, if I'm not wrong, and other chain is testnet of Symphonia. That's it. So if I select the right chain, so I'm change the value of the state. That's it. And also the code that I checked that if user try to change the chain, for example, user try to change to Ethereum chain, so I'm gonna push the notification that hey, you don't have to do anything, right? Because you can't. This is a tricky part, right? If you know that if you build a front end, the apps you have to use API. It's called arbitrary interface to call smart contract, right? This API is also public, right? So I have to build it within my component. So I push my API within the GitHub content user, this is why it's called transparency, right? If this API is not correct or they do something weird, this is one line of defense that can protect the user execution. This is the thing that actually is only two functions, right? The first function is called query balance off. It means that I query that my wallet has NFT on that or not. Another function is like a mint NFT, right? It's called mint token. Basically, just only two functions to bottle. If I click one bottle, the trigger function. If I click another bottle, it just trigger this function. So I'm gonna explain to you about mint. The first one is mint, right? This contract is the contract that Node already deployed in the first session. So I need to call the contract, this contract address, right? And I have initiate the contract interface, which is this is the parameter that I have to put. This is the body of API, is contract address, and also this one is get signer. It means I get the signer from MetaMask that allow private key to sign transaction. And I call mint NFT, right? If if in first session mint NFT is built in the remix, right? You execute the contract, but this one is built within a BOS, which is JavaScript, right? So if you trigger that point and this is passed, right? So it execute the contract right away. I'm going to show you in real action if you want to see. I'm not sure it's going to work or not. Please bear with me if it doesn't work. Sorry for that. If I want to mint, I have to change to our own nice. And I'm going to click mint. It should work. It's not working, I'm sorry. This one I can explain to you is testnet, right? Basically, it's like there are some slowdown within the layer of Chainlink testnet. If it's correct, it's gonna appear a MetaMask that you have to put to pick the button and sign. But it is called error. It's called estimate get error. Do you want me to dig deep what the estimate get error is? Have you know that? I try to make it pass, but it can't. I'm sorry. Yeah, but anyway, let me explain something to you. I think in case someone listening and try to understand what is the cannot estimate get error is. This error is appear in console, right? Because I track them here. I catch an error. If this line of code is not passed, I'm gonna throw the error in the console, right? This is error console. This is not too technical section, so internal estimate gap is mean that if you execute some contract or execute some function, they try to reproduce every phase step that you're going to pass. So estimate gap fails mean that underlying function within the Chainlink or within any contract that you call is error, they're gonna show you estimate gap fail. It means that they try to reproduce the process, but it's not passed. So it means that even though you can put too much gas or maximum gas, no matter how much that you will push it in, it's gonna throw error anyway because the underlying protocol, underlying function is already there. So this is going to not pass. But imagine if it passed, right? It's the same process as already minted. Yeah, still not passed. Sorry about that. If it passed, right, it's mint. And after that, it's going to show the picture. So that's the thing that should work. I'm sorry. Please try that in your home, right? If it works, show me again. Okay, so the mint is passed, right? If it already passed, it's going to show the transaction in CCIP, the Chainlink. You can get the hash and you can check the status here about transaction that you executed in here. And also the last part is about query balance, right? This is the way that you shouldn't do by you shouldn't copy me because it's very hacked. What do I do? The thing that I do is I check the wallet and the contract. If the wallet has some NFT or not. Because ERC 721, if you give only your wallet address, they're going to show you how many NFT you have in that contract, right? but they don't return specific NFT token that you have. So it means that if I want to have to make sure that the owner have NFT and which ID, I have to make a further in coding. It's like I have to cache the all transaction in NFT and I have to index them and display. So basically this code is just like I'm checking if they have at least one NFT and I just show them. So this is like very short and not a proper way to show the proper token ID of NFT that user has. And yeah, that's it. I think if I go back again and on Sephora, and view. This means that this wallet I already have at least one NFT. So the code is about checking that if the return of the hex is not 0, this user has some wallet. This wallet has some NFT. That's it. It's really stupid code for check NFTs. Don't do that. This is just for education purpose. Because when it returns, it's not returned to int, right? It's returned to hexadecimal format. So basically, I don't want to change anything. So just compare against the result that I have. Yeah, basically image stored in IPFS, which is I think known from CCIP. They already deployed the image on that address. And this is the image that we get query from contract. And yeah, that's it. I think this is all that leverage the BOS component, explore about how to use with CCIP. So I think it's done for today, I guess. Is there any questions that you want to ask? Sure.
Here, like BOS is like infrastructure for.
Sorry.
Yeah, like BOS is infrastructure for making the components. And when I working with smart contracts, I'm working with smart contracts that have been made before.
Yes.
Okay.
So BOS component is infrastructure for front-end component.
Okay. And like if I'm using React, like for example, yes, I can create application and I can implement like either JS, for example. And why do I need this? Because of components?
Why do you need BOS, right?
Yeah.
Because it's free. It's almost free. You need a NIA to pay a gas.
Okay.
Basically, if you're a builder, you need a NIA to put the contract, put the JavaScript on blockchain. That's the thing that you only need.
So you do the same with Chainlink.
Yes, something kind like that.
Okay. Some kind of question that you ask Chainlink. You kind of doing some looks like layer 0. They were the first one who got an idea about cross-chain messaging.
Almost correct if you want to compare with layer 0, but it's not correct yet because it's just only front end, right? We did not doing layer 0 is like they secure each chain, right? They secure asset each chain. But this one is like instead you have to buy a server or rent a server to host your website. You don't have to. You just deploy the hosting front end component within the NIA.
Last one. And how you talked in the beginning, we have a lot of layers.
Yep.
And this each layer is blockchain.
No, it's just a component that explain to you, not the blockchain. The blockchain layer is the last one. Sorry.
So like, I understand that CCIP has a blockchain with the messages and has a cache on the one blockchain and another blockchain if you make some transaction with like a CCIP in the middle.
No. Basically, they're just a big front end engine that they can call anything, not just only blockchain. So basically, big server to host any component of any user. User has to pay near very small fee to host the component. That's it.
Okay.
Good question. Good question. Basically, for example, if I want to build the same website like this, right? The thing that I have to do, the first one is I have to install Hardhat in my computer, or even I have to install React.js or any front end that I like. I download the component that I download the library that I have to use, right? I have to find some hosting website, right, to host my website, and I have to protect with the DDoS attack, right? And I have to pay for every month for a server. So basically, I have to pay a lot of things before I push my product to the market, right? But this thing is just like you build it, and that's it. You go to sleep. Let me handle it for you. Sure.
You said you're using JavaScript.
Yeah.
You said you're using JavaScript,
Yeah.
but I can see there's some JSX that you're actually using,
Yes.
and ethers that you did not import. I see
Yes.
some import statements.
Correct.
So is it kind of opinionated that you have to use those, or can you also use a few?
Interesting question. Actually, I have to tell you that you can write in JS and you can write some embedded library that they already have, like either JS they already built in. But if you use Vue, it's possible, but you have to find a way to import that library into this kind of component. In my opinion, in my defense, I think you have to stay with React. Kind of, this may be more flexible for you, or plain JS, or JS is possible, but if I'm answer not correct enough, I'm so sorry, because I'm a back-end developer and I have to try to write front-end, so it's kind of ugly for you. I'm so sorry about that. Yeah, but basically, I think as I think you can stay with plain JS, also JS is possible. But if you have to use Vue and you have to import Vue libraries, it might not possible, I guess. I'm sorry, I cannot. I'm not sure. I'm not front-end. But if you have to import some style, I think some team already tried. You can import Tailwind in here and you customize CSS with Tailwind possible. But I'm sorry, but I can't answer that. You can, but if you want to do, you have to do in a gateway layer, so it's like more abstraction. If you focus on component, I think stay with JSX is a good idea. I'm sorry if I'm not answering clear. I would like to be better front end, but in real life I can't. I prefer stay with back end. It's like more direct for me. Front end is like art for me. You see, I mix many things, right? I use. If you see my code, it's very messy, right? I use a sync function, right? And I use mix with I use sync function, right? And sometimes I use .NET. Basically, it's like spaghetti style. You should stay with one, right? Shouldn't mess with like that. And some hacker, some builder told me that is there support TS TypeScript? I said that it might be, but it's tend to be missing right now. In future, maybe it's possible because BOS just announced. I think just only 6 months ago. I'm not sure. It's only 6 months. It's only announced in 2023, which is 6 months ago. So basically, it's just six months is just only like this. I think it's pretty powerful already. TSA gonna coming for sure, I guess, but maybe not their priority yet. But I cannot answer for them. Just my speculation. Okay, pizza coming already. Yeah, I think it's you just take about 10-20 minutes to wait for a pizza. If you're going back now, pizza gonna be full in the room, right? And you can hang out, networking if you want to ask something. I think from Nia, from myself, and also from Chainlink, you can